so delighted to introduce you to our guest speakers tonight. We have three amazing scientists with us, two in person and one via Skype. So first of all, I'd like to introduce you to our guest who came over from Knoxville. She's a geologist at the University of Tennessee in Knoxville and also a co-investigator on the Mars Science Laboratory mission. Please welcome Linda Kaye. And from NASA, who also brought some goodies for us in the lobby. I really appreciate that. We have a planetary scientist from NASA's Marshall Space Flight Center who has studied meteor impact sites on Mars, the Earth, and the Moon. And asteroid 6186, Barb Cohen, is named for her. Please welcome Barbara Cohen. And finally, joining us from Silicon Valley in California, from NASA Ames Research Center, he is a member of the Kepler science team. The Kepler course launched by NASA in 2009 to discover Earth-like planets orbiting other stars. He's here somewhere, I think. Please welcome Steve Howell. Are you there, Steve? Hello. Hey, thanks for joining us. And then we have the Belcourt's Zach Hall, who's going to get the conversation started tonight. And Zach did most of the Science on Screen planning and programming, so I'm very happy to have him leading this discussion tonight. So Zach will get it started, and I'll take audience questions after you guys get going. Thank you.
Well, thank you all so much for being here. This is a ridiculous turnout, our second year in a row of a sellout opening night to Science on Screen. So it's just such a pleasure to have you all here. But perhaps even more impressive, and probably the reason you guys actually came out, we have incredible guests tonight. So I think we'll just start out by, maybe if you guys want to say sort of brief description of the work that you've done in the past, and if you want to touch on how that may or may not actually be relevant to the movie we just watched, feel free. But the point of this series is to open up the conversation about the real science behind all this popular art form that we all go out to the movies in droves to see. We're opening up the conversation and trying to connect what you guys do in real life to sort of collective fantasy that we all get to see on the big screen. So I guess we'll start with the Wizard of Oz looking guy up here. Let him say a couple words, and then we'll open it up to our physical attendees. So,
all right. Well, hello, everybody. It's really great to see you. I can actually see. It's pretty cool. So you might have seen the banana early on. See, I always think of a banana when I think of the Alien movie, because they have that like banana head there. So, oh, it's a little delay between the laughter. I see. I'll have to wait when I tell my joke. Okay, thanks. Good to know.
I'll let you know if you're bombing.
So this movie, let me tell you what I'm doing. So I work at NASA Ames Research Center in California. I'm a little south of San Francisco. And I work for the Kepler mission and the new K2 mission, and we are finding planets that orbit other stars. So we think a lot about alien life, and we think a lot about what planets might be habitable and what planets might not be habitable. And I have to say that we do not think about creatures like the alien creature living on any of those planets. We often think about people, things, or whatever like us, because us is what we want to find. We don't want to find things like the alien because it's mean and nasty, which is, of course, the way we portray aliens ever since the 1930s and 40s in science fiction movies. So there are a few comments I'd like to make about the movie, but maybe I'll save those until we hear from the other guests.
Yeah, let's just go through pretty quickly, and then we'll get to the sort of meat of the discussion. So, Linda Kaye.
Hi, I'm Linda. I'm probably the oddball of the bunch. I actually only joined planetary science in the broad sense about 8 years ago with the Mars Science Laboratory mission, on which I'm a co-investigator. But in my what I call my real life is spent looking at some of the oldest rocks on Earth to try to figure out both how we can identify life in ancient rocks or evidence for metabolisms in ancient rocks, and to also look at how the Earth's ocean and atmospheric chemistry has changed through time in response to having life living on this planet.
All right. So Barbara Cohen.
And I'm Barbara Cohen. I work at NASA Marshall Space Flight Center, just a little bit south of us. I'm a planetary scientist. I'm a geologist, so I work with rocks from other planets. Some of you probably got to hold some of them out there. The rocks come to us as meteorites, and I split them open and study their interiors and how they formed and when they formed. And we haven't found life in any of them yet. We may someday, hopefully. And I also work on missions. I work on the Mars exploration rovers, which were the precursors to MSL, and use those as our avatars. We get those fuzzy pictures just like you would have seen someone following around someone else as well. So that's what we do.
All right, great. So I guess let's talk a little bit about the movie before we break into that real world thing. I mean, obviously this isn't what you're looking for. But what does extraterrestrial life to you guys look like in a sort of the real sense of it, and how do you think that sort of relates to the sort of overblown metaphor of this movie, or whatever it is? Just run with it. Sorry. We'll let you start, big guy. That's you. Sorry.
Oh, big guy. I'm the
big guy. You're the.
All right. So first of all, Barbara, I thought it was cool that you said you split rocks open. I thought that was very appropriate to the Alien movie with the chest and all that, you know. So,
I was thinking about the mining. I'm like,
movie.
oh, what are they mining? What are they bringing back?
I'm going to completely avoid your question and talk about something else instead.
Thank you.
So how many of you, I can kind of see you there, how many of you can raise your hands, know about the star Zeta Reticuli? How many people?
Barbara's raising her hand.
There you go.
Nerd.
Okay, I see a few. All right, so if you heard in the movie early on when they were they woke up and they kind of came out of their sleep and they thought they were near the Earth, right? Because that's when they normally wake up and they're ready to go home. But they couldn't find the Earth on the star maps and anything like that, and they said, "Oh, we're lost." And then they looked through the star maps and they searched for the Earth and they said, "Oh, I know where we are." And they said very quickly, they made this reference to, "Oh, we're near Zeta Reticuli B or Zeta Reticuli 2. And I had never noticed that in the movie until I watched it this weekend a lot, so I was kind of geared up for you guys. That's a very famous star. In fact, that particular star, Zeta Reticuli, is in the constellation of Reticulum, which is a reptile. Right, so it's kind of a cool connection there to the reptile-looking alien. But that's a star that is thought to be the home of the Greys, the gray aliens with the big slitty eyes and all that, right? And that came from the first case of an alien abduction in the early 1960s. I can see that some of you probably remember the early 1960s. Good for you. Others of you don't. But in that movie, in that book, if you ever read this book called The Interrupted Journey, it was the first case of an alien abduction. And it was a couple in New Hampshire, I think, that were abducted by aliens. They were on the spacecraft for 3 or 4 hours. And one of them noticed on the side of the wall in the operating room a star map, which I thought kind of weird. You're navigating by a map if you come all the way to the Earth and it's in your operating room, but whatever. That map they reproduced in this book. And a high school teacher in Ohio built a 3-dimensional model of all the nearby stars in their garage and showed that the only way that map could be interpreted was if you were looking at the sun from the star Zeta Reticuli, which happens to be a star much like the sun and happens to be relatively close. It's only 39 light years away. So that star is the star that's now believed to be the home of all the gray aliens that come here to the Earth and abduct people. So they made this really clever reference to that in the movie Alien.
Has Kepler observed that?
I'm sorry?
Has Kepler observed that?
You know, it's funny you asked that because Kepler has not observed that, and it's because Kepler didn't look there. It wasn't our field of view. But in fact, we had a particular person who has called over the last 5 years. I hear from him about every month, who wants to know what the latest information is from Kepler on Zeta Reticuli. And every time I tell him we haven't observed it, he tells me I'm covering up and keeping things secret. So.
Because you know that's what we do.
That's
we
right.
hide
That's
everything.
So speaking of what you do, how do you take this movie from a scientific sort of angle?
Yeah, so we'll get back to your question now, so thanks. So from a scientific angle, there's a lot of things that are really required for life. It's a pretty amazing thing, and some people with life on our Earth will talk about the fact that we need to have a moon so we have tides. We need to have a magnetic field so we don't get bombarded with deadly radiation. We need to be the right distance from our stars so we can have liquid water on our surface. There's this whole range of things that you have to have. Yet, while that sounds very special and unique, we've identified over 5,000 planet candidates orbiting other stars in just a very small part of the sky we've looked at. If you take that number and you extrapolate it to our entire galaxy, one of many, many galaxies, there are something like 20 million planets that are kind of like the Earth in size and distance and all that. So I think that other life is probably highly likely. Now, is the other life silicon-based? Is the other life an evil alien like the Alien? Well, makes great science fiction movies, but we're not evil and alien, so why would we expect other life to be evil and alien?
I don't know. I think I take a little bit of an objection to that because, if you look at the history of mankind, what happens when one group goes to another country and visits another one? They kill the men, they rape the women, and they steal all the goods. So do we really want to meet aliens like that?
Well, that is funny because in the movie, when they're going out to visit the alien ship, they walk out and they do all this sort of checklist. And one of the things they say is make sure we get the guns, get the weapons out of the locker, right? So it's clearly that if we meet something unknown, the first thing we want to do is kill it. So yeah, I agree.
And then eat it.
Sure.
Just for good measure.
No, I have to admit that I have not seen this movie since I was an undergraduate when it came out. So it has been a long time since I've seen this movie.
Like 3 years ago, right?
But I have a couple of different reactions to it now. A, I'm really glad my 10-year-old was not here because he would never sleep again. But secondly, working on the Curiosity rover, the one thing that really strikes me is anybody who thinks that anything can happen quickly and easily in space is just full of it. I mean, nothing happens quickly, nothing happens easily. Anything that might even remotely go wrong gets practiced 10 million times. And quite frankly, joining a mission team for the first time, this drove me crazy. I'm one of the PIs on one of the cameras on board. And I remember when we first on Curiosity pulled out the arm, one of our cameras captured this little thing on the ground. And from the first pictures, it, honest to God, looked like a Phillips head screw. And so we're like, oh my gosh, we took the arm out on this rover and we've lost a piece of hardware. And so we spent 2.5 weeks trying to diagnose what that piece of hardware was. And I was sitting one day working with the rover planners, and they said, okay, well, we've decided that we can finally move the arm, and so we want to move the arm and take the camera that can get really close and put it right down in this thing and get a good picture of it. And they wanted to take like 47 different pictures. And so I quietly explained to them about depth of field on a camera and that they really only needed one picture. And they'd see it all in 3 dimensions and it would all be in focus and that would be okay. I mean, nothing happens quickly on missions.
Yeah, do you have any experience with the frustrating sort of slow-going process?
No, it's wonderful.
No, it's incredibly cool. But nothing happens quickly.
One of the things, both of us work on the Mars exploration program, and that's a little bit closer to home than the planets that Kepler's finding. Although I hope we go there someday. And of course, we don't think that there's macroscopic, cats and aliens and stuff life on Mars. But one of the things that we're really interested in is exactly out of this realm of possibilities of what does it take for life to arise and how quickly does it arise and what are the building blocks that you need and what are the conditions you need. Mars is one of the best places to look for that, to see if those conditions in the past were were good enough for something to arise, maybe single cellular life, maybe little colonies or mats. Those are the kinds of things that we're looking for on Mars in our Mars exploration program, starting with the Sojourner rover, the little Sojourner rover, just to see if there were conditions on Mars that were changed in the past. And there were. And the Mars exploration rovers are to look for past signs of water, and that's what we have found with Mars exploration rovers. And the Mars Science Laboratory and Curiosity is there to look for the building blocks of life. Are there organic materials still surviving on Mars, and are those building blocks of life and energy there? And there are. That's the great discoveries of Curiosity.
And that's all really well and good, but like I said, as somebody who spends most of my life in my science looking at some of the oldest rocks on Earth, one of the problems, one of the things that we see in the literature and on blogs, and heaven knows all the things that we see on the internet about the Mars missions is not only are we hiding everything from you, but if you work on one of these teams, you're always having to explain that you are in fact not a life detection mission. That there really is a difference between looking for an environment that may have been suitable for life or looking for building blocks that we associate with life and actually finding life. And I think that the easiest way to really explain that is if we take the Earth, and if we take the ancient Earth, this is a planet that we know was teeming with life for at least 3.5 billion years. And when you go to a rock that is relatively ancient, and I don't work on the oldest rocks, most of my time is spent on rocks that are only about 1.5 billion years old, a mere 1.5 billion years old. But to pick up any rock and actually find any evidence of life on a planet that we know was covered with it is so difficult. And so we really face this problem when we start looking at other planets, and it really truly is still a question, whether or not we have the capability of recognizing it, even if it was there. And because we have this nasty thing on planets called taphonomy. Taphonomy is basically everything that happens to an organism after it dies. And it is incredibly hard to make a fossil out of anything. And so, well, we have one fossil right back here, but he works on telescopes.
Sorry, I couldn't help myself.
See, I don't know. Is he sitting here like giving me rabbit ears behind my head, or? But it really is a terrific challenge.
One of the things that we do with Kepler all the time, and the new repurposed Kepler of K2 is we find planets, and we don't, we never can see these planets. We find them by somewhat of an indirect means, and all we really know about these planets is their size, and we know where they orbit, so how close or how far away they orbit from their star. We don't know if they have atmospheres. We don't know if there's life on their surface. We don't know any of that. And in fact, the Kepler field of view, which is the one that was stared at for about 4 years, essentially every planet in that field of view will never really be studied in any great detail because they're all very far away. So you will never get measurements for most of those objects as to what that planet really is like. But what Kepler did teach us was that planets are everywhere. If you go out into a parking lot, or you go out and look up, you go out and find insects in the world, or plants, what you find is that the smallest ones always outnumber the biggest ones. So to me, it's not a really surprising result, although we now know that the number of small planets greatly outnumbers the number of big planets. Planets like Jupiter are actually fairly rare. Planets like the Earth are actually fairly common. And so if you want to look for planets that you can follow up and study and actually measure their atmosphere, measure and see if they have oxygen or chlorophyll or something, you want to find planets that orbit stars that are very close to the Earth, relatively speaking. So the repurposed Kepler mission, this mission called K2, is looking at objects that are fairly close to the Earth. We're finding planets around stars that are maybe 5 light years away or 10 light years away. And I know a light year is a long way. 1 light year is 6 trillion miles. It's a long way. But if a planet was 5 light years away, you can actually imagine that we could communicate with life on that planet. We send a message. It gets there in 5 years. They send us an answer. It gets back in 5 years. So every 10 years, you have a conversation going on. So once you start the conversation, of course, you have something pretty continuous that goes on. So at least these planets that K2 is finding are relatively close by, and there'll be planets that we can actually measure their atmospheres. We can get a measurement to see if their atmospheres have compositions that are much like the Earth's, whether they have free oxygen, for example, in their atmosphere. So I think we're really close. I would bet a decade away of finding a planet that has an atmosphere that shows us that not only does it have an atmosphere, but it has an atmosphere that's sort of amenable to life.
I think we're going to go ahead and open it up to questions now, just so everybody gets a chance to pick the brains, the amazing talent up here on stage. So, so raise your hand, and Allison will bring you the mic, and we'll talk to you. I didn't know he was going to be such a jokester.
I think all of that venting of gas is just a really bad idea.
Yeah, what is that?
Why is there water dripping all over the electronics?
It's just, yeah, I mean...
This is bad practice. Bad engineering.
Yeah.
I think that the mining part of it actually is pretty fascinating. It's not scientifically implausible, but to have to go as far as they did, it implies that they've totally mined out the solar system, which is, I don't know, maybe it's 8 zillion years in the future. I don't know.
Okay.
The most fascinating part of the movie to me is this was the first science fiction movie, the first, that had a woman that led it and was the hero and took over and kicked the aliens' butt. That was the best movie.
Barb and I have no problem with that.
Not implausible.
It's about damn time, huh?
Space mining is one of these things that there's a whole industry growing up right now around it, and you hear it a lot. Planetary Resources, a couple other places want to go mine asteroids. And so my personal take is I'm buying stock in landfills so that we can go mine our precious metals from them. It's a lot of money to go out into space and to mine things and to bring them back to the Earth. So if you go out into the parking lot or into your backyard or whatever, every rock that you pick up has almost every element in it. They're in very, very small concentrations, of course. That's why they're not ores. And on the Earth, when we get ore deposits, it's because we have something that pulls those elements out of other rocks and concentrates them all together. And that's usually hot water flowing through the crust on the Earth. We don't have a lot of examples of that on other planets or asteroids to concentrate those elements. So you'd have to, to bring that back to mine it, you'd be bringing back like rocks from your backyard.
Essentially the whole thing.
Yeah, seriously, like go mine the parking lot. It's like the same kind of thing.
Because we've talked about, I think all of us have said something about, what is actually required on a planet. We presume an atmosphere, we presume water. But there's something else very special about the Earth that may make a large difference in whenever we think about the extent to which life could evolve. And that's we have plate tectonics. And plate tectonics is a great positive and a great negative. He's
demonstrating.
Oh, okay, that's fine and dandy.
That's like a real scientific way of doing that.
As Barb just said, as far as minerals, what we need to do is concentrate them. Those are concentrated in large part because of plate tectonics and because of the way we move heat and move water around our planets. One of the big problems with Mars as a planet in terms of long-term habitability is that Mars does not have plate tectonics. It has a very thick crust. And there's a lot of question about the extent to which you could keep an active biosphere on a planet that doesn't have some sort of plate tectonics.
No, I want to just add addendum to my little rant, sorry about that, is that asteroid cores. So if you guys got to hold one of those iron meteorites out there, the really heavy one, those do have concentrated metals in them. And that is something that we don't get on the Earth. And that's pretty much ready to go. It's barely even ore. It's really all just metal. So there are metal asteroids out there that would be really interesting to mine. But I don't know if it's cost effective yet. I do know there are papers out there.
You'd have to tow it back, I think.
You'd have to okay, so NASA has a plan to do that.
Oh, they do?
We do.
My bad. Like I said, I'm only part-time NASA.
There is a plan out there to bag an asteroid or to grab a piece of an asteroid and bring it back to lunar orbit so that we can go up there and touch it and fiddle with it and possibly even work on our mining techniques and things like that for the future.
Yeah, it's going to be really tough to make any money. You know, if you take a typical asteroid and you would even make that asteroid out of solid gold. So you spend all your life going out this asteroid, you drag it, you bring it back, not even this solid gold asteroid that's the size of, half the United States or something. But of course, by doing that, you've now dumped the gold market. So now your gold that you did all this work to do is now worth nothing because now there's so much gold.
You could be the De Beers of space and just hold on to it and ration it out.
I'm going to be flippant because I just am, but people can be jerks. And this isn't to be taken lightly, because when you work on a mission and you work with 250 other scientists and an untold number of engineers, sometimes there's going to be a jerk, and you have to figure out how to work together. I haven't run into any robot jerks
Two
yet.
maintenance guys were pretty classic blue-collar workers. And I thought that was a really interesting part of the movie where they gave, of all these people where you're way in the future and all this technology and that, these two guys were, scheming as to how they could make the job last longer and how they didn't have to do any work and stuff like that. I thought that was a pretty realistic part of the movie.
I had forgotten how much people smoked in older movies.
Something that really resonated with me was when they get out and they're like, "Oh, it's only 2 kilometers away. Let's go." And I'm like, "Heck yeah, let's go!" Right? And you go and you see the big ship or building or whatever it is, the big structure, and you've seen paleontology digs where you're all very careful and you mark it off and you get the brush and the gloves and they're like, "Oh, let's just go."
Only vertebrate paleontology. My husband's a paleontologist. Okay. This is not. They mostly just take a hammer and beat the crap out of rocks.
But I thought it was very. I thought it was very human and something very much in the mode of exploration, where you want to go to it and you want to see it and you want to keep going in and okay, yeah, it may be dangerous. Maybe I'm stomping over things that I shouldn't stomp over, but I'm right there with them. I'm like, I know this alien is going to be in there and it's going to kill us. I still want to see it. Heck yeah, I want to go. I want to see that planet. I want to walk around there. Yeah.
And I love Barb. She was actually a postdoc at the University of Tennessee when I first started as a faculty member there. So we've known each other for a long time, and I absolutely love Barb, but she's insane. She's insane, and this is one of the things I most love about joining the planetary community. There's a huge number of absolutely brilliant, insane people, and I remember asking a friend once, why is there such absolute passion in this community? And the answer I got was, well, these are all the people that realized that Starfleet Academy wasn't actually real, and this is the closest they can come. I mean, I'm a field geologist. I mean, I've spent, if you add up the months I've spent in the field, I've spent about 5 years of my life in Arctic Canada, in the middle of the Sahara, in the Andes of Argentina, and the fact is, you don't. The primary rule of field work is if you have to put your field notebook in your pocket, you're doing something that's unsafe and you shouldn't be doing it. And, for one thing, 2 kilometers, oh, give me a break. Look how long it takes one of our rovers to go 2 kilometers. I mean, we're talking months and months and months here. And I wouldn't be caught dead doing any of that.
Well, let's. That brings up an interesting point, and I just want to get a brief sort of reaction from you guys. We're a movie theater. Part of our mission here is to sort of open people's minds up to the idea of movies, the sort of effectiveness of movies in different dimensions. But you brought up a good point with, everyone nerds out about space. Everyone loves it. It's great.
Everyone loves it.
I mean, but movies show us space and give us this opportunity to sort of think about it in this sort of overblown capacity. What are your favorite space movies? Let's just do that.
I'm going to go first.
Steve?
Okay, I'll go first. My favorite space movie, but my absolute favorite movie of all time, which happens to be a space movie, is The Day the Earth Stood Still. I like that movie because it has an alien who's like a regular guy, right? He shows up and it has a good message. We're a bunch of idiots. Knock it off. I think that's a good message. He kind of tells the Earth to, quit thinking you're so cool and big and all that. Now, I mean the original one, not the like hack remake with Keanu Reeves. Sorry, the original one. That's really great, and I am a science fiction movie fan, and one of the great things I like about science fiction movies is they are a window of society into how people view science, how they view what's important in science, and how they view scientists. So I would encourage you all to watch movies from the 1900s up through Alien, where a woman finally is in charge, and even further than that, and look at the role of various people. I mean, women is a classic one to look at the role, where in the 1940s there were 5 scientists in a laboratory. They all had white coats on. The men were at the equipment and the women's bringing coffee, but they're all scientists, right? And so if you really look at the progression of that and how people view science and what they think are important roles of how science influences humanity. So I think that's a very interesting part about science too, science fiction movies. So you should tell your theater people here to show you movies that could cover this span and get people to talk about them all.
Any quick reactions from you two, and then we'll open it back up so people.
Go, Barb.
Oh, I'm not a science fiction fan. Don't hate me.
I'm sorry. I have a 10-year-old. I watch 10-year-old movies. It was actually a little piece of plastic. Most of the bundles of wires in the rover are wrapped essentially with shrink wrap plastic, and so it was this little sort of crinkled bit of shrink wrap plastic. But the way the light shined on it and its slightly iridescent properties made it look like metal.
Okay.
So, it was litter.
You guys
it was
laugh.
litter.
You guys laugh, but all we're working with is an image, a picture. And one of the great things in geology that we do is the act of picking something up and doing this. So when you pick up a rock, you get a feel for how heavy it is, how dense it is compared to things that you're used to. You get a feel
If you're me, you lick it.
Coprolites?
I don't care. It's been dead for a long time.
You get a feel for how coherent it is, if it's a tough rock or if it's crumbly. And then when you rotate it, you get sunlight glinting off facets of the rock or not. Is it matte? Is it shiny? Is it lustrous? Are there crystals? How big are the crystals? All of that tells a geologist an enormous amount. And with
even
the rovers, it's so frustrating because all we can do is take a picture of it over there.
And even if you don't go as far as picking up something, you would be surprised how important peripheral vision is. When I joined the Mars mission and I really didn't know what it was going to be like, I was told, looking at things on Mars is like looking at the world through a straw. And it really is. It's like having your hands tied behind your back and having a straw in front of your eyeball, and that's all you can see, and you have to physically move if you're going to see anything else. And I think, if anything, it's made me a much better geologist, because you start working on Mars and you realize that some of the most fundamental bits of geology, the things that they teach you in your first class in college, my parents met in a geology class in college, so I was 5 when I knew I was going to be a geologist. I told my kindergarten teacher that that's what I was going to do. And the earliest things you learn, that there are sedimentary rocks and igneous rocks and metamorphic rocks, when you've got a photograph, you can't necessarily tell. It's incredibly humbling that, as smart as you might be and as active as a research program you might have, that all of a sudden you can't necessarily identify a rock anymore.
So we have a mission called Lunar Flashlight. On the Bag and Asteroid mission that I told you about before, what we're using for that is this giant rocket. We're making a new heavy lift rocket. It's called the Space Launch System. That's what's replacing the Space Shuttle. On its first test flight, which is going to be in 2017, 2018, it's not going to have any crew on board. It's for obvious reasons, so it's just going to take the capsule with no crew inside. And so it doesn't need a habitation ring, and so it's going to carry a bunch of CubeSats. And so it's going to launch these CubeSats, and they're going to go to all sorts of different places. It'll be our first opportunity for interplanetary CubeSats. CubeSats are these small 10 by 10 by 10 centimeter kinds of things. rings. You can stack them up, and they're in low Earth orbit. There's a lot of students are doing them now. A lot of colleges are doing them now. They're very low cost, very easy to build, and we're going to send them interplanetary for the first time. One of them is just going to actually just go as far as it can. So those are on track to go, and it's one of our ways of trying to learn more about the solar system in ways that aren't necessarily giant missions like MER and MSL. They're not great for everything. They have their uses, but that's something that you guys can look out for when that rocket launches.
Great. Well, I think that's a good place to wrap it up, and I just want to say thank you so much, Steve Howell, Linda Kay, Barbara Cohen, for being here with us tonight. Thank you.
Thank you, guys.
Thank you so much.